Hello everybody, this is Dr. Nur Badsha. In this lecture I'll talk about, continue the previous lecture which was about measure of central tendency, which is the part of data description. Uh, okay, so in last lecture we have discussed the last topic. It was weighted mean and then properties of mean as well. Let's talk about now how do we find mean from ungrouped frequency data. In this case, observations would be given and their corresponding frequencies will be given. Okay, and I discussed a bit in last video as well, where I said that frequencies may be considered as weights, whereas weights may or may not be considered as frequencies. Okay, so let's suppose the given data, given observations xi, they have corresponding frequencies fi. So as I said, fi would be considered as the weights of these xi, so that is obviously a weighted mean. So you will simply multiply every observation with corresponding frequency and then divide it by the sum of frequencies, keeping in mind in this case sigma f, that means sum of all frequencies, which would be n. So summation x into f, it means basically multiplying every observation with corresponding frequency and then adding them and dividing by the sum of observations. So that would give you simply mean of ungrouped frequency data. What do we do when we have group data? So we basically link group data with ungrouped frequency data, and then we would find mean, and you would learn that how do we do that. So in case of group data, what do? We first introduce, we first find midpoints of each class, and then we consider those midpoints as the given observations, and then multiplying those observations with the frequency as we discussed in previous slide, in case of data with the frequency and observations. So the midpoints could be found as upper limit plus lower limit divided by 2, or upper boundary plus lower boundary divided by 2. So from there you would simply find the midpoints, and then you would multiply midpoints with corresponding frequencies, and you will get mean, adding them and dividing by some of the frequencies. So let's suppose if we consider this data, these are the classes given, which are 7 classes. The class width in this case, if you find that, would be simply 5, 10.5 minus 5.5, or 15.5 minus 10.5. That would give you class width. And these are the frequencies. So the first step is what you would find midpoint. Midpoint can be found as 5.5 plus 10.5 divided by 2, which is obviously 8. The next midpoint would be found by using these two class boundaries. So it's 10.5 plus 15.5, which would give you 13. But if you see from here, from the two midpoints, the first midpoint was 8, the second midpoint is 13, and the class width is 5 as well. It means you don't need to find all the class width. Once you have found the first one, you would simply write 8 and then plus the class width plus the class width plus class width. You see 8 plus 5, that is 13. So the next class midpoint would be 13. The next one will be plus 5, it will be 18, and then plus 5, and so on. So you see we'll be having 8, 13, 18, then 23, 28. The common difference is what? That is simply the 5. Now multiplying 1 with 8, 2 with 13, 3 with the 18. So now it's the same thing what we have in case of ungrouped frequency data. Okay, and then we add them together, 8 plus 26 plus 54 and so on. The sum will give you what? 490, where sum of the frequencies would be 20. Keeping in mind n in this case will be sum of the frequencies. It is not the number of classes or number of groups. So 490 divided by 20, that would give you 24.5 miles. So mean of this data is what? That is for 24.5. Okay, sometimes the data is numerically very big or very small, which obviously lead a student to a researcher to a high magnitude or high numerical values. When you add them or you multiply by something, sometimes an observation would have a big frequency. So obviously we would be interested in transforming the data. Now, what would happen if you transform data? From third property of arithmetic mean, you know that if you transformed a data linearly, the mean will be accordingly transformed linearly. So that's what we call a change of origin. Change of origin basically means you have to add or subtract a number, whereas change of scale means you would multiply or divide every observation of the data by a number. Now, how do we do that? We basically introduce a new variable by transforming like xi minus a. We are subtracting a number, so that is a change of origin, whereas dividing by h, that will be change of origin. Okay, and then the new data, the new transform data, which is denoted by ui, we would find simply mean of this transform data, which would be easy to find, would be simple to find, and then we would find x bar from that, which can be done is multiplying h here and adding this a to here. So we get x is equal to a plus u h, and then x bar would be a plus h u bar. Okay, so you would find u bar first, and then by using this relation, x bar is equal to h u bar plus a. Now the question is, what should a and h be? So generally it is open, you can take anything. It might be from the data, it may not be from the data, the same thing here. But the best options are, the suitable options are, it's better to take a, an observation from the data which has the maximum frequency, whereas taking h is the class width. And that's obviously optional, you can take any number for h or any value of a. Okay. Right, so let's do an example for this as well. What would happen if we use this shortcut method? So let's suppose these are the weights of apples. From 65 to 84, there are 9 apples. Their weights is in grams. 85 to 104, there are 10, and then 124. And so this is the data given, right? Now, what do we do? The first step is you would find the midpoints, right? You know how to find mean by using direct technique. So simple, the midpoints are what? 65 plus 84 divided by 2, that would give you 74.5. The next midpoint will be 94.5, and then 114.5, and so on. And the corresponding frequencies are these. So what do? We multiply these midpoints, which are considered as, are assumed as xi. They would be multiplied with the corresponding frequencies. So 74.5 multiplied by 9, you would get 670.5. The next one is 94.5, will give you, multiply by 10, would give 94.5. And then we add all these together, so we get 7350 divided by 60, which would give you 122.5 grams. So if you use the direct method which we discussed earlier, so the mean would be 122.5 grams. Now what would happen if you transform this data linearly? So you see the maximum frequency is of this observation 114.5. So we take this one, you can take this one obviously is a, whereas class width in this case is 20, because you say 84 minus 65 plus 1, because in this case we are given class limits, not class boundaries. In case of class limit, how do we find class width? That's the upper limit minus lower limit plus 1. Whereas in case of class boundaries, you will be simply taking upper boundary minus lower boundary, don't need to add 1 in that. Okay, so let's do that. We would get the same result or maybe different. So yeah, we will be getting same result because of the rule. So we take this one as a, and h will be simply the class width, which is 20 in this case. So we introduce this transformation that ui equals xi minus a, where a will be taken as the observation or the midpoint with highest frequency. So you see 114.5 has been taken as a. So subtracting 114.5 from every observation and dividing by 20, because 20 is the class width. So 74.5 minus 114.5 and then dividing by 20 would give you minus 2. You may pause the video and you should check it whether it is minus 2 or not. So 74.5 minus 114.5 and then dividing by 20 would give you minus 2. 94.5 minus 114.5 divided by 20 would give you minus 1, and so on. So you see that now the values of u are very simple. They are low in magnitude, or they are low numerically. So minus 2, minus 1, 0, 1, 2, 3, 4. So you can find the product with the frequency without using calculator. You can simply take their they are squares as well, they are sum as well. So everything is very simple now, you see. So we have 9 into minus 2, minus 18, minus 10, so on. We add them, that would give you 24. Now what is the mean of u? So it is 24 divided by 60, multiplying that mean by the corresponding class width, which is 20, and adding that origin you have taken, which we called a, so adding that number to it. So the mean of original data would be what? It's 114.5, selective one. 24 by 60, that's the mean of u, which is u bar, and multiply by 20, which is the class width. So we get 122.5, which is exactly the same answer what we had a bit earlier. Okay, now let's talk about geometric mean. How do you find geometric mean in all these cases? So keeping in mind that geometric mean is suitable when the data has a geometric behavior, okay, and it can be found for a certain raw data xi. You would multiply all the observations and then you take its nth root. So x1 multiply by x2 up to xn, and then whole power 1 by n. Keeping in mind this measure is applicable to positive data only. It is not applicable to negative data. If the data has 0, obviously you cannot apply it. Now multiplying those numbers which are numerically very big, so this number will become certain very big, and then you are taking its nth power, so that sometimes becomes too hard to do it. So what do? We simply apply log on it just to convert these products and powers into sum and product. Okay, so it will become what it will be, what, 1 by n log of xi and so on. So that is the log of g, but we are interested in g, so you will take anti-log. Now you see, if we convert this to sigma notation, we have 1 over n summation I equal to 1 up to n. This is log of xi. Now if I consider log of xi my yi, okay, if we simply call this quantity as or yi, now what would happen? You see, we are having a simple formula of arithmetic mean, that is summation yi divided by n, which is basically y bar. But keeping in mind, what are y's? Y's are basically log of x. It means, in other words, we can say that geometric mean, which is g, is the anti-log of arithmetic mean of logarithmic data. If you apply transformation of log, you get new data, because you should know from maths that if data is geometric behavior, then applying log on it will have arithmetic behavior. Okay, so we are having arithmetic mean here. So it means that geometric mean has something different criteria concept. We simply apply log on it, and then we find arithmetic mean of that logarithmic data, and we have to transform back. We have to apply an inverse transformation, which will be the exponential or anti-log. So the main steps are what? You would simply apply log on the given data. You would find arithmetic mean of that logarithmic data, and then simply you take its anti-log. For example, this is the given data for marks of different students, 9 students. So n in this case is what? That is 9. So if you would apply a log on all these observations, log of 45, log of 32, log of 37, and so on. And then we have 14.387, that's the sum of these one, dividing by 9, because you would find arithmetic mean. So 14.387 divided by 9, which would give you 1.59856. So that is the arithmetic mean of this logarithmic data, and we apply anti-log on it to get what? Geometric mean, because as I explained earlier, that geometric mean of the arithmetic mean of logarithmic data is the geometric mean. So in this case, the geometric mean is what? It is 39.68. You see that geometric mean is smaller than arithmetic mean, because for this certain data, arithmetic mean is 40. If you add all them together, dividing by 9, it would give you arithmetic mean of this data. The same thing can be generalized towards frequency and group frequency data as well. The only step you would do, the only transformation you would do, applying log on the midpoints or applying log on the given observations, and then multiplying with the frequencies, adding them, and then dividing by the total number of observations. okay, to get the arithmetic mean, and then apply anti-log to get geometric mean. So the same thing can be done as I explained for a certain observation xi with having frequencies fi. The geometric mean is basically defined as like that: x1 power f1, x2 power f2 up to xk power fk, and then whole power n. Keeping in mind in this case n would be simply sum of the frequencies. But again, if the data x1, x2 up to xk are numerically very high, or the frequencies are very big, so obviously it would give you some issue. So applying log on both sides again, and then converting power into product and product into sum, we get anti-log of 1 over n summation I equal to 1 to k fi frequencies multiplied with yi, where yi are a transformed data applied by transformed by log, and then we take anti-log as well. So this is the geometric mean formula. So you see the same thing, it's to simply apply log, multiply by frequencies, and then you find the sum of those products fi log xi, and then you divide by total number of observations to get arithmetic mean, and then at the end you would take anti-log. So let's suppose we consider this data for weights of Saram, that is 50, 63, and the number of heads are given as 5, 10, 5, 15, 15. So what do? You would simply apply log on this one and multiplying by these frequencies to get this table. I hope everybody can do that. So it's 50 log of 50 multiplied by, sometimes you may need this column as well, because you can do it directly. Log of 50 multiplied by 5 would give you this one. Log of 63 multiplied by 10, that would give you this one. Log of 65 multiplied by 5 would give you this thing directly, and so on. So we are interested in the sum. So sum of these will be 99.21 dividing by the sum of frequencies, which is 50. So 99.21 divided by 50, whatever you get from that, take anti-log of it, because we have to find geometric mean. So in this case, geometric mean is what? That is 96.43. Okay, what about the group data? Geometric mean from group data. So the only difference is the xi's will be what? That would be the midpoints of every class, what we have done in case of arithmetic mean. So if you learned arithmetic mean, geometric and harmonic mean are simple transformation of that method. You would apply transformation, and then you would find arithmetic mean of that transformed data, and transformation will be done through a function log of x. So let's consider that example again. So the weights of apples, of 60 apples, from 65 to 84, that there are 9 ones and so on. So we first find the midpoints, okay, and then corresponding frequencies. So what do? We apply log on it. So log of 74.5 multiplied by 9. Again, this column is not that much important. You can directly jump from here to here, or you can use calculator directly to find the product of these two columns. So you can find it as well. So the sum of this quantity will be what? That is 124.2483, dividing this by 60 to get 2.0708, and then applying anti-log to have 117.7 grams. The geometric mean for this data is 117. If you remember, the arithmetic mean was 122.5. Here we have 117.7. So geometric mean is always smaller than arithmetic mean. Okay, what about the next measure after dispersion we discussed earlier? That was harmonic mean. So harmonic mean is what? The first step is we apply transformation on it, right? And the transformation is the inverse transformation. We take reciprocal of every observation, then we find their arithmetic mean, and then we take its reciprocal back, because we want to have mean in the original space. So you can write in this form as well, or the same process what we discussed, you learned in geometric mean. In geometric mean, we apply log, and then we take arithmetic mean, and then we take anti-log. Here we first apply inverse function on the given data, then we find its arithmetic mean, and then we find its inverse again to go back to the original space. You must remember from your previous classes that reciprocal of harmonic mean is harmonic behavior data will have arithmetic behavior. The same thing in frequency data, even though in group frequency data these xi's would become the midpoints of each class or each group. Okay, for group data, same formula will be used. The only difference is what the xi will be the midpoints of the classes or groups, and fi be the corresponding frequency of the class or of the group. Okay. So if we do example, I hope it's a very simple example. We first take reciprocal of it. So 1 over 45, 1 over 32, 1 over 37, and so on. And we have the sum of these reciprocals, that is 0.22. And then we take what? Divide it by 9, because the number of observations are 9. So dividing this quantity by 9. Okay. And then you take reciprocal of it to get 39.3663. In this case, you can use this formula as well, dividing by number of observations by sum of this quantity, or you can simply take arithmetic mean of this data and then you take its reciprocal. It's the same thing. Okay. How do we do that in group data? So the concept is same. You would first find midpoints. Okay, midpoint of each class. The first one is obviously 74.5, that is 94.5. So what would you do? You would take reciprocal of all these quantities and then you would multiply by 9. Whereas a short method is what? You don't need to take the reciprocal. You simply divide this one by this one, which means the same thing. 9, the frequency divided by the x values, that is 74.5. So it basically means frequency multiplied by inverse of this quantity. So without including that inverse column, that means 1 over x column, we directly go for the frequencies, the midpoints, and then the final product. So we have 74.5 and 9. So 9 divided by 74.5 would give you 0.12081, whereas 10 divided by 94.5, 17 divided by 114.5, and so on. So these will be the values of fi by xi. When you add them, right, you would find arithmetic mean of this data, that is dividing this by 60, and then you take its inverse back to get 113.11 grams. So keeping in mind that harmonic mean is smaller than geometric mean is smaller than arithmetic mean, or the other way around, arithmetic mean is greater than geometric mean is greater than harmonic mean. I hope you enjoy this lecture. You would have learned something from the lecture. If you have any questions, you can simply post those questions in the comments box. Keeping in mind that this lecture has 2 videos, the full, part 1 and in part 2. So before you watch part 2, you should watch part 1 first, and then you come to the part 2. Thank you very much for being with me, and hope to see you in next video.